Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be talking about how to write the expression of an equilibrium constant using the law of mass action. So here's the third practice problem. So again, I just want to reiterate where this is coming from. So the law of mass action basically says that rates of reactions are based on the concentrations. So this includes forward and backwards reactions. And so if you have an equilibrium, then both of those are happening at the same time. So when we're talking about the equilibrium constant is going to be based on the concentrations of your reactants and products. So the first thing I want to point out is that your equilibrium constant K is very generally speaking going to be concentrations of products over the concentration of reactants. And I talked a little bit more about this in more detail in another video. So if you want to check that out, please do. So that's the first thing. It's products over reactants. But in addition to that, each of product and reactant, the concentration is going to be raised to the power of the coefficient. So whatever their coefficient is, that's the power that you are going to raise them to. Okay, so coefficients are powers. They're going to become powers. That'll be an arrow. So coefficients become powers. And the second thing I want to point out is that solids and liquids do not go into your expression for K. So no solids or liquids. No solids or liquids. And this is because in a manner of speaking, their concentrations are constant. All right, so those are two things I want to cover. So let's go ahead and write the expression for this equation here. So here we have some propane gas. So maybe this is the propane gas you're using on your grill, or you're cooking outdoors, or whatever the case may be. So you take the propane gas, you react it, you burn it in the presence of oxygen, and it becomes carbon dioxide and water. All of this is gas. So you can include all of these in your expression for your equilibrium constant. If there was a solid or liquid, you wouldn't include that. For example, if the water here was a liquid, you would not include it in your expression. So let's go ahead and write the expression for K for this reaction. So K is then going to be equal, as I said, products over reactants. So we'll do the products first. So here we have carbon dioxide, so we'll do the concentration of carbon dioxide. And we know here that it has a coefficient of 3, so then we write the power of 3 here. So we're going to raise this concentration to the power of 3. Now next we have water vapor, gaseous water, so we're going to write the concentration of H2O. Because gases can be thought of as having a concentration, right? So if you have a balloon with a gas in it, you can change the concentration by squeezing the balloon, making the volume smaller volume. You're compacting the molecules in closer, so you can think of that as more concentrated in that area. So here we have a coefficient of 4, so we're going to write that as a power of 4. Now we're done with our products. Next, reactants on the bottom. So we're going to start with our propane. So that's going to be C3H8, the concentration of that. And we have a 1 coefficient, so therefore we're going to have a 1 exponent or power. We don't write the ones, so we just leave it like this. And then finally, we have oxygen gas. So this is going to be O2. And we have a coefficient of 5, so we're going to write a power of 5. And that, ladies and gentlemen, is the expression of your equilibrium constant for the combustion of propane gas. So that's it for this video. I hope you enjoyed the video. I hope this was helpful in helping you understand how to write the expression for K for a reaction. If it did, if you liked this video, if you enjoyed this video, then please, by all means, like the video. Hit that like button. Also, make sure you share this with your friends. Subscribe to my channel. Make sure you hit that notification bell. And when you do, make sure you click all so you can be notified by all the videos I put out. And finally, make sure you leave a comment below. Ask me questions. Let me know what you think. I would love to hear from you. Thanks for joining me and have a great day.